Good afternoon, all of you, and here is an introductory lecture of sequencing series. Okay, so I'll be coming with the basics lecture. The first lecture consists of basic introduction to sequence, series, arithmetic progression, and geometric progression, and a lot of very good level of problem solving. The second lecture, which I usually give after that, is the recurrence relation. So let's see what basically recurrence relation is. As the name suggests, reoccurrence relation. So something which reoccurs again and again. The best example that comes to my mind is to eat an apple. So you have an apple and there is a rule of the game. So rule of the game is you cut it into half, and eat it. Right? So let's say if I give apple, now you start eating and I'm like, wait, you have to cut it into half. So now you have new half apple, the first step. Again, the moment you are like, okay, let's eat, you have to cut it into half again. So we have again quarter of it, and you have to repeat this process again and again, right? So now the great question is, if you continue doing so, when you are going to eat the apple? So eat when you are comfortable. So eat it when you are okay with it. Okay, and this is just the basic philosophy behind recurrence relation, and this relation is used in most of the JEE problems. Right, so I'll not go into the detailed solution of general linear recurrence or non-linear recurrence because that's not been included in the syllabus of JEE Advanced, but some specific simple level of problem can be done by recurrence, and as a part of sequencing series, it should be taught. So let's start with the simple problem. I call it a staircase problem. So by a problem, we'll try to appreciate the situation. So you have a staircase, let's say stairs, right? And let's count, let's say this is the starting point and Mr. Golu is here. So we have 1, 2, 3, 4, 2, 3, 4, 5, 6. Let's make it a staircase of 10, 7, 8, 9, 10. So here we stop. Okay, so finally Golu has to start from this point and he has to finish here. Okay, so how many such steps he can take? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th step में वो वहाँ पे पहुँच जाएगा. The rule of the game is like Golu is only allowed to take a step of 1 or 2. So he's only allowed to take a step of 1 or a step of 2. A step of 1 or 2 means he can start from this point, and in the first journey maybe he can just take a jump of 1. So he'll move to the next stairs again 1, 1, 1, 1, 1, 1, 1, 1, 1. So you can see like in this way he can take a step of 1. So 1 followed by 1, followed by 1, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To reach this. Or he can take a step of 2. So maybe in the beginning he'll first take a step of 2, say land on this stairs, and now again he took a step of 2, and then a step of 1, 1, 1, 1, 1, and finally reached. So it might happen like 2, 2, 4, 5, 6, 7, 8, 9, 10. So now the question is, in how many ways Golu can end up with this game? Like he can start from the lowermost point and he has to reach to the uppermost point. तो इतना कितना तरीका है. Now of course you can give one of the solutions by case making. So let me first do case making. Method 1 will be when there are no 2's, like Golu take all steps of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. इसमें तो there is only one way in which he can do that. Okay, that is case number 1. Case number 2 will be when there is exactly 1, 2. So exactly one step of 2 has taken, and rest is 1. So 2. Then we have 8 ones, 1, 2, 3, 4, 5, 6, 7, 8. Now in how many ways it can be done? And this clearly can be done because how many space we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 9 space, we can select, Mr. Golu can select any dot where he will take a step of 2. So let's say out of 9, if I select any one point, 9 choose 1, that will be the number of ways of taking one turn of 2 step one move of 2 step and the remaining move of 1 step. So that is actually 9C1. Is this clear? Because I could have taken 1, 2 and all remaining 1, or 1, 1, 1, 1, and the last step maybe from here jump to 2. Okay, so many cases will come here. Case 3, when you have exactly 2 2s, so 4 is already there, 5, 6, 7, 8, 9, 10. Right? So we have 6 into 8. Out of 8, again I can select any 2 place to give to 2. For example, we have 1, 2, 3, 4, 5, 6, 7, 8 place. Out of 8 place, you select any 2 place and give it to 2. So the remaining place definitely it has to take 1 move. Similarly, we can take case 4, and that will give exactly 3 2s. So 6 is already consumed. 5, 6, 7, 8, 9, 10. Right? 6, 7, 8, 9, 10. So now we have 4, 3, 7 out of 7. I'll select any 2 place. Similarly, last case is when we have 2, 2, 2, 2, 8, 9, 10. So out of 6, I'll select any 4 place for 2. And we'll have case 6 when you have all 5 2s. So you don't have an option here. Okay, and that has been shown by this red in the beginning. In the step of 2, 2, 2, 2, 2, you can show by a new color. So you jump 2, 2, again jump to 3rd move, 4th move, and 5th move. Right? So there is only 1, 2. Now just we need to count always. So let's count 1 plus 9 plus 8c2 is 8 into 7 by 2. So that will give you 28. 7c3 will be 7 factorial by 3 factorial into 4 factorial. So you can see 5, 6 into 7 by 6, that will be 35 plus 64. So 6c2 is same as 64. So 6 into 5 by 2. तो ये 10 आ जाएगा. So 6 into 5 by 2 is 15. 15 plus 1, that will give 16. So if we'll add all of them, you can see is 29 and 37, 37 and 10, 47, 47 and 6 is 53, 53 and this is 88. Let's count again. 11. So it's 10, 38, 35 and 16. 89. Okay, so this counting is going to give me 89. Now we can clearly see, is there any other way of doing this? So let's try with other method. So let's try this problem with other method using very interestingly called recursive method of solving this problem. यहाँ पे what I'll do is, let's draw this picture first. Okay, so in this method what I'm going to do is, let's suppose an denotes the number of ways in which Golu can go from a starting point to finishing point, provided there is n staircase, n stairs. Right, so instead of 10, first I'm generating the problem to it. So hash means number of ways in which Golu can go from a starting point to finishing point with n stairs. Right? So this is how I am defining what is an. Similarly, if I ask you what is an minus 1, so it's number of ways in which Golu can go from a starting to finishing point provided is n minus 1 stairs. This directly follow from the first definition of n. If I ask what is an minus 2, so it's number of ways Golu goes from a starting to finishing point provided is n minus 2 stairs. Like this. So let's say if it is a5, so it's specifically tells number of ways in which Golu can go from a starting to finishing if we have 5 stairs. Now the beauty of all this is any an or any ak denotes fundamentally same physics. Okay, it's going from a starting to finishing. Now how many possibilities are there for Golu? Let's say if Golu starts at a starting point, he has only 2 choices in his life. Maybe the first move, choice regarding first move, right? So first move either he can take with a step of 1 or he can take a step of 2, right? Let's say after first move, if Golu is there, if after first move Golu comes at this location, so now how many stairs is yet to be covered by Golu? It's n minus 1 stairs. Okay, so in an, number of ways in which Golu can go from first to last, provided it has n stairs, Golu will have two choices. Basically, he can take the first move of 1 stairs, and in this so many choices will be there. And when he has taken the first move of a step of 2, so 2 stairs, again we'll have so many choices for Golu. Now after first move is a step of 1, let's say for Golu, and we don't know actually how many such counts are there, right? Similarly, first move is 2, and next move can be anything. It can be 1 or 2, 1 or 2, 1 or 2. Because after first move, Golu has full freedom to select, again restart the journey, right? Restart his life of movement. And after this, it's basically same initial problem, but apple is being half, right? Now you have n minus 1 stairs, and again from this point you can take a jump of 1 or 2. Yes, so now you are getting a feel like after first move, the number of ways in which Golu can go from now new location to the final location is nothing but a n minus 1 according to our definition. So this is number of ways. Right. Similarly, if Golu has selected to jump in the beginning as his first move, then the number of ways in which he can go is now a n minus 2. Because after this, how many stairs he has to cover? It's just n minus 2 stairs. So fundamentally, total number of ways in which Golu can travel is sum total of two mutually exclusive ways. Exclusive मतलब इसको उससे कोई लेना देना नहीं है. Because number of counts in the first all starting with 1 will be definitely different from all starting with 2. Let's say starting of 1 can be 1, 1, 1, 1, all 10 in the first choice. Or maybe 1, 1, then 2, 2, and then remaining. Maybe 1, 2, 2, 2, remaining. Or 1, 1, 1, 2, 2, and remaining. So all these starts from 1. Okay, now remaining is basically again a n minus 1 choice. So new choice. So finally I can tell a n equals a n minus 1 plus a n minus 2. And this is your great recurrence relation. Right? अब इससे क्या फ़ायदा हो रहा है हमको? Like let's play a game. Okay, suppose if I in the previous question I wanted a10. So instead of n, if I'll keep 10, it's basically a10 equals a9 plus a8, which you can feel again. Like suppose if you have 10 stairs to start with, so first move can be 1 stair or 2 stair. If it is 1 step, then remaining move can be covered with a9 ways. And if it is 2, it can be covered with a8 ways. So total a10 equals a9 plus 8, as simple as that. Now again, unfortunately, neither I know a9 nor I know a8. So again, what I will keep, I will put n equals 9 in the original system. So now we have a9 equals a8, a9 minus 1, and a7. Again, what is a8? It's a7 plus a6. Again, what is a6? a6 plus a5. a6 equals a5 plus a4, and we can keep on doing. So let's do. a3 is a2 plus. We can go further, but that will invite a0. It means there is no stairs, so we can't comprehend easily. Now you see, like finding a1 and a2 is very simple, because what is a1? When we have only one stairs, right? It means this is a starting point and this is finishing point. So in how many ways Golu can do? A1 means number of ways put n equals 1. So that Golu goes from a starting to finish when we have one stairs. So for one step we have only one choice, like directly jump with a step of 1, because no step of 2 is available. So a1 is 1. This is our base case. Means this is a case when you will be comfortable in eating an apple, because you have to go to one base case where you should decide, like let's eat an apple. Otherwise you will never eat an apple, right? So there must be some starting point. So here a starting point is a2 and a1 for us, because that's easily known to us. So what is a2 now? When we have 2 stairs. Okay, so now when we have 2 stairs, again from a starting to finishing point, either I can take a step of 1. So that is one case, 1 and 1, or I can directly take a step of 2. So that's another case. So final a2 is 2 ways are there, either 1, 1 or direct 2. So now we have a1 as 1 and a2 is 2. So that makes a3 as 3. Now you put a3 as 3 over here, and with your predetermined value of a2 2, that makes a4 5. So you know, like it's a reverse chain reaction. Okay, so just from a2 and a1 case, we can now find any values. So as you can see, the sequence a1 is 1, a2 is 2. So next is 1 plus 2, 3. The next is 5, 8, 13, 21. Then we have 34. Then we have 55. And we have 89. In fact, this is the 10th attempt. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually my answer was 89 here. That is the value of 18. So it's really surprising, like this STR problem of 10 STRs is fundamentally the STR problems of just single STR or double STR. It means basically, okay, solving that great problem of 10 STRs is nothing more than solving first or second STR problem. Okay, so this reoccurrence of the same genetics again and again is known as recurrence relation. ठीक है, अब यहाँ पे again I could have given you the question. In the same question, JEE wala could give you, let's suppose n is the number of ways of going from starting to finishing by GOLU in n STRs. One limit n tends to infinity an by an minus 1. तो फिर ये इंटरेस्टिंग क्वेश्चन हो जाएगा. अब देखो कैसे, अब इसको लिमिट से कैसे जोड़ देगा, इन द रेशियो. नाउ वी नो an is already equal to an minus 1 plus an minus 2, right? So if I'll divide an by an minus 1, so what we'll get, 1 plus an minus 2 by an minus 1. Now let's take limit n tends to infinity both sides, limit n tends to infinity. Now we know since this sequence will be finite, because if you'll see the ratio, you can see 2 by 1 is 2, 3 by 2 is 1.5, this is 5 by 3, again something. So this ratio, as you can see, it tried to saturate towards something. So we need to know that saturation value. Now we know clearly when n is very large, then we'll have terms like an plus 1, an minus 1. So for large n's, this ratio will almost be similar, like an by an plus 1, limit n tends to infinity an plus 1 by n. This can be proved mathematically also, but यहाँ पे field से भी आप देख सकते हो, क्योंकि this ratio of sequence, because since this ratio is going to saturate because terms increases, hence the ratio difference will be almost tending to 0. Or what we can do is this, if you see the gap between an plus 1 by an minus 1, that will tends to 0. It means those both limit is same. So using that concept, I can tell, let's suppose this converges to limit L, then 1 by, this is ulta of L, and by addition of limit I can distribute limit because both exist. So 1 by L, that gives me L square minus L minus 1 is 0. So what is L? 1 plus minus root over 5 by 2. Now clearly this ratio is not negative, so the final answer is 1 plus root 5 by 2. And that's called as golden ratio 5. So you know this, the limit of the ratio of number of ways in which you can go to n stairs divided by number of ways you can go to n minus 1 stairs when n is really large is very golden. So this has got a special name called golden ratio. ठीक है, अब यहाँ पे आपको इसको as an option they can also create and merge this with quadratic expression. कैसे? Because you know there is a clause for formula. In fact, they can write n as alpha n minus beta to the power n by root 5, where n is a natural number, where alpha and beta is the root of the equation, root of this equation, x square minus x minus 1 equal to 0. So very surprisingly, you'll see like this an again satisfy this like recurrence relation. How? That is not very difficult to see, because if alpha and beta are the roots of this equation, I can multiply this equation with x to the power n minus 2. So if I'll multiply with x to the power n minus 2, we are going to get x to the power n minus x to the power n minus 1 minus x to the power n minus 2 equals 0. Since alpha satisfies this, so alpha to the power n minus alpha n minus 1 minus alpha n minus 2 is 0. Beta ka power n minus beta n minus 1 minus beta ka power n minus 2 is 0. If we'll subtract both equations, I'll get alpha n minus beta n minus alpha n minus 1 minus beta n minus 1, or फिर इधर minus alpha n minus 2 minus beta n minus 2. Now we wanted root 5 into picture, so we can just divide this with root 5. By definition, this is n, so you can clearly see it's an minus 1 minus an minus 2 is 0. And that is basically same recurrence relation as what we got initially. So I did actually reverse engineering. So in option C, they could give like then n satisfy this, right? The JEE advanced problem or some comprehensive problem. So indeed, from very basic, you don't need to have any pre-knowledge of recurrence relation to solve this problem. And in that sense, JEE advanced is called really JEE advanced examination because they don't want much prerequisite from you. Okay? So this was a good question which shows not only how to use recurrence relation, but it also shows how it can be used for, relating different topics of mathematics and integrating with the theory of equation or limit concepts. Of course, this AN is very well-known series. It's known as Fibonacci sequence. So this sequence is known as Fibonacci sequence. On the similar sequence, JEE Advanced has already asked numerous problems in the last year. Okay, and many property of Fibonacci sequence can be even explored using matrix algebra. Right, but again, just to keep it within JEE, discussing the reference. Okay. Usually I discuss this when sequence and series class I take. So this is just a introduction lecture and it shows you like how my classes basically goes. ठीक है. अब देखो जैसे आप एक और क्वेश्चन को JEE Advanced can ask in the similar fashion. Let an be the number of strings. Hash I'm writing with number of. Let's say this string is B1, B2 till Bk, where Bn belongs to either 1 and 2, and such that sigma Bi I equal to 1 to k equals n. So first decode the problem. What is the meaning of problem? Let an denotes the number of strings. So suppose instead of n, if I put n equals, let's say 4. So let's read the problem again. So what is A4? A4 be the number of strings such that B1, B2, B3, B4, number of strings of this fashion, where all these Bi's or Bn belongs to 1 to 2. Right? Actually this is Bi for I equals 1 to k. Right? तो अब कैसे string आपको दिखेगा? वैसे it can be 1 1 1 1 or it can be what? 1 1 2 or it will be 1 2 1 2 1 1 2 2. Now can you feel like it's same as a staircase problem? Right? It's same as a staircase problem because now is sum of these Bi is equals n. So basically it's asking in how many ways the sum of these string status will be equals n. So for B4 it should be 4, for B5 it should be 5. इसका मतलब इसको हम डिकोड कर सकते हैं ऐसे. We have 1 2 3 4 starting point, stopping point, right? So we have got 1 2 3 and 4 stairs. Now in how many ways again someone Golu can climb from here to here such that he is allowed to take only 1 or 2 steps. तो फिर देखो again it's either 1 2 3 4 or he can take 1 1 and then 2, or he can take 1 here and then 2 and 1, or he can take 2 and 2. So देखो ये तो same question हो गया. So here if I ask what is A10, so it's exactly same answer that you have given before, right? So A10 was we have already seen is 89. तो A10 is 89 over here. तो यहाँ पे exactly same recurrence relation you can develop. ठीक है. तो यहाँ पे जो recurrence relation आएगा it will be exactly same as what we have done. So an will get as an minus 1 plus an minus 2, and better is defined for n greater than equal to 3. Okay, where a1 is 1 and a2 is 2. अब देख सकते हो how I have converted this problem to a staircase problem and then solve the staircase one. Right? Up, let's try again one more just to show you how to use this idea. Let's suppose Sn denotes number of n digit binary number that do not contain 3 consecutive ones. Okay, so again you can repeat the same question for 2 consecutive ones, and that will be again interesting Fibonacci sequence where it will be directly a type of that you think. Okay, but here just to make a different example, is n digit binary number that do not contain 3 consecutive ones. So not having 3 consecutive ones. Okay. Now first you develop the recurrence relation and the initial condition that uniquely define the sequence. So basically you will have some sequence. Sn will be related with maybe Sn plus 1, Sn plus 2, or Sn minus 1, or Sn minus 2. So this kind of recurrence relation first we need to develop. क्योंकि ऑप्शन में मे बी यू आर नॉट रिक्वायर्ड टू सॉल्व इन लाइक दिस जे एडवांस एग्जामिनेशन और ISI और इसी में, बट दे कैन गिव ऑप्शन लाइक S10 is S9 plus 2 is 8. इस टाइप का क्वेश्चन दे हैव ऑलरेडी गिवन इफ यू सी द पास्ट ईयर्स. सो आई एम नॉट टेकिंग एनी टॉपिक विच इज इररिलेवेंट. ठीक है, हेयर अगेन आई कैन गो विथ लीनियर रिकरेंस, नॉन लीनियर रिकरेंस, लेकिन वो यूज़ नहीं है. तो अभी आपको उतना ही पढ़ाएंगे हम इवन इन दिस वीडियो लेक्चर. मोस्टली आई प्ले विथ JEE एडवांस कंटेंट. आई स्टार्ट नेक्स्ट यूट्यूब चैनल लेटर जहाँ पे इट विल फुल्ली ओलम्पियाड कंटेंट. तो वहाँ पे नंबर थ्योरी एंड ऑल दैट फ्रॉम वेरी बेसिक्स विल डू. लेकिन ऑन दिस चैनल आई विल नॉट डाइल्यूट इनिशियली विथ एनी अदर कंटेंट अपार्ट फ्रॉम JEE मेंस, एडवांस, ISI एंड CY. मेनली आवर फोकस विल बी ऑन एडवांस मेंस वहाँ पे. तो लेट SN एंड डिनोट्स. अब हाउ टू फील द रेकरेंस रिलेशन, राइट? सो कैन यू गिव अ ट्राई. यहाँ पे कैसे हम रेकरेंस रिलेशन का इस्तेमाल कर सकते हैं, ऐसा सोच सकते हो क्या? तो देखो, वी काउंट द नंबर ऑफ रिक्वायर्ड एंड टर्नरी नंबर इज देयर, राइट, इन विथ 2 डिफरेंट वेज. यहाँ पे तो बाइनरी नंबर है दैट डू नॉट हैव 3. बाइनरी नंबर मीन्स नंबर्स कंटेन्स ओनली 0 and 1. तो फॉर एग्जाम्पल 0 0 1 1 0 1 1, this is allowed. So this is a number of length 1 2 3 4 5 6 7. Okay, so of length 7 this number is allowed because it has not 3 consecutive one. But this number will not be allowed. 0 0 0 0 1 1 1. So this is still having length 7 but we have 3 consecutive, so this is not allowed. So how to defend with this number? ठीक है, तो इसमें आप सोचो कैसे इसको हम डिफेंड कर सकते हैं. तो ये भी इट इज़ अगेन वेरी इंटरेस्टिंग. लेट n बी द नंबर ऑफ रिक्वायर्ड नेस्टिंग्स. तो इसमें आप स्टार्टिंग कैसे करोगे? तो देखो, वी काउंट द नंबर ऑफ रिक्वायर्ड n डिजिट बाइनरी नंबर, ओके, इन 2 different ways. One count is SN, and for a second count we can observe that there are 3 types of n digit binary number. देखो कैसे, क्योंकि we can have number starting with 0 एक तो, and of course we have starting with 1. Now starting with 0 also will have different types, right? क्योंकि 0 पे we can have start with again 0 0 or we'll have 0 1, right? With 1 also we can have 1 0 or 1 1 and remaining again something something. Let's say I'm taking SN, like all those number of length n I'm trying to calculate. ठीक है, तो those begins with 0. अब जो 0 के साथ शुरू हो रहा है सपोज, ठीक है, या फिर ऐसा भी होगा 1 1 के साथ होगा, फिर 1 0 के साथ होगा. आफ्टर 1 0 अगेन विल हैव 1 0 1 एंड ब्ला ब्ला ब्ला, और 1 0 0 ब्ला ब्ला ब्ला. So this is valid thing. But with 1 1 we can't have 1 1 1. This is not possible. So with 1 1 we must have, after 1 1 we must have 0. There is no other option, right? So with this little experimentation, like this is experimentation, I am not yet solved. So this is how we have to start a problem. Now the point is not to develop a recursion, to connect SN with its neighbors. You try to establish a case where the physics exactly repeats. Like after certain point आपको पता ही नहीं चले जो ओरिजिनल क्वेश्चन और इसमें डिफरेंस क्या. ओनली लेंथ ऑफ क्वेश्चन शुड बी स्मॉल. जैसे इफ आई सेग्रीगेट इनटू 3 पार्ट्स, सपोज फर्स्ट पार्ट, सेकंड पार्ट, थर्ड पार्ट, अभी हम आपको दे ले लॉजिक व्हाई आई शुड सेग्रीगेट ओनली टू 3 पार्ट्स, व्हाई नॉट 4 पार्ट्स और 10 पार्ट्स. सो कंसीडर ऑल दोज नंबर विच बिगिंस विद 0. ओके, तो आफ्टर 0 how many length will have? n minus 1 length. Now after 0 actually doesn't matter what I start with. If I start with 0, it's back to the same problem. Because with 0 again 1 1 3 consecutive should not be there. If I start with 1, it's still the same problem. Okay, so I can tell Sn is fundamentally composed of one root Sn minus 1. because once 0 is fixed at first, so all cases which has 0. Next is Sn minus 1 ways of counting it, such that no 3 1s are consecutive. Those who begins with 1 0 now, let's say with 1. अब 1 में प्रॉब्लम क्या होगा, आपको दो केस लेना होगा. ओके, आइदर नंबर्स विच स्टार्ट विथ 1 विल बिगिन विथ 1 0 और विच स्टार्ट विथ 1 will begin with 1 1. Now after 1 1, here I have restriction because I can't put 1 over here. So if number is 1 1, next number has to be 0. There is no other choice. You can't see 1 1 1 as any valid case because that's invalid, right? But with 1 0, again I have full freedom. It means now it's again similar question with a length of n minus 2. तो यहाँ पे number of case जो बनेगा that is Sn minus 2. ठीक है, अब 1 1 के पास कितना केस बना, अब देखो ये ब्यूटीफुल है. We'll have remaining n minus 3 options now, freely to play, because again after 0 the story again same. Here you are free to put 0 or 1. Okay, here we are free to put 0 or 1. Here you are free to put 0 1 after 0. But after 1 1 you are not free to put, you are constrained. So freedom was not there, right? Now with that freedom I can tell this full question is composed of 3 questions. First place 0, remaining anything you choose. First place 1 0, remaining anything you choose. First place is 1 1, then has to be 1 1 0 and remaining anything you choose. Hence Sn is Sn minus 1 plus Sn minus 2 plus Sn minus 3. And this is the recurrence relation for all n belonging to natural number which is more than equal to 4. Why I am not keeping less than 4? क्योंकि फिर n s minus 1 और s 0 आ जाएगा, उसका कोई significance नहीं है फिजिकली. नाउ क्वेश्चन इज वेरी इजी क्योंकि बेस केस आप आराम से फाइंड कर सकते हैं. ओके, यू कैन इजीली फाइंड नाउ S1, S2 and S3. Let's calculate S1. S1 means we have only 2 string, binary string. So either it is 0 0 1, right, or 1 0 or 1 1 or 0 0. तो ये काउंट करना तो अपने लिए काफ़ी आसान हो गया. ओके, बट what it means, S1 is number of n-digit binary number not having 3 consecutive 1. ठीक है, तो S1 का क्या वैल्यू आएगा बताओ, एंड S2 का क्या वैल्यू आएगा. S1 में बेसिकली वी हैव ओनली वन केस, दिस इज S2, राइट, दिस इज S2. So S2 is 4. S1 में we have only one string, so 0 1. Anyway, it's not consecutive single, so S2 is 2. And what about S3? S3 में apart from 1 1 1, will anything work? Of course it work. So we have basically 2 choice here to put 0 1, 2 choice to put 0 1, 2 choice to put 0 1. So we have total 8 choice. Out of 8 choice, 0 1 1, 1 0 0, whatever works except 1 1 1. So it will be 7. Now with this initial boundary condition, I can find even S4. तो S4 क्या हो जाएगा? It is sum total of 1 plus 2 plus 3. So that's, you can clearly see 9 plus 4, 13. Now once you know 13, again S5 you know. You can give S4 plus S3 plus S2. So it's 7 plus 4 plus 13, which is 24. So like this you can calculate any value. ठीक है? So that is very interesting and that's fun also to all these calculations. अब again JEE वाला will be very smart. Okay, like they can give you a recurrence of this, like they can give you alpha beta gamma is the root of equation like, you know, x cube minus x square minus x and minus 1 equal to 0. So if this has got alpha beta gamma as the root, so clearly again if we'll multiply with x ka power n minus 3, we'll get x ka power n, x ka power n minus 1 minus x ka power n minus 2 minus x ka power n minus 3 equal to 0. And since alpha beta satisfies, so keep alpha beta gamma and add. So we'll get Sn, right, minus Sn minus 1 minus Sn minus 2 minus Sn minus 3 in 0. Where what is Sn? Sn is alpha n plus beta n plus gamma n. So the point is again this recursive relation can be connected via cubic equation now, unlike quadratic equation before. And that can be a source of JEE question. In fact, this is known as characteristics equation for the above linear recursive relation. तो ये syllabus में नहीं है. Those who are preparing for an Olympiad वो कर सकते हो. So I hope the point is very clear, like how recursive relation can be introduced in sequence and series, and how practically we can feel it और फिर प्रॉब्लम को कैसे सॉल्व कर सकते हैं, ठीक है. इट्स नॉट ओनली लिमिटेड टू like just sequence and series, but very often sometimes even binomial question in trigonometry can be solved with this, ठीक है. So that's the power of recursive relationship. So one such problems which I'm getting reminded of is in binomial theorem we have root 2 connections or even Newton's sum as well. For example, suppose we have cubic expression x cube plus x plus 1 equals 0. It has got root alpha, beta, gamma, and we define Sn as alpha ka power n plus beta ka power n plus gamma ka power n. This is what I was talking about before. And now I ask you, what is S11? Means find alpha 11 plus beta 11 plus gamma 11. Of course, you can do with a cube plus b cube plus c cube, but that will be very difficult because alpha cube to the power 11 by 3 you have to take. Or maybe you'll go to alpha to the power 9 plus beta ka power 9 plus gamma ka power 9. Multiply with alpha square plus beta square gamma square to produce alpha 11. And again, remaining term you have to trade off. Right? You have to manipulate. So it will be huge manipulation. But once someone realizes that since I can multiply this expression with x to the power 8. So to create x11 plus x9 plus x8 equal to 0. Since alpha satisfies, alpha 11 plus alpha 9 plus alpha 8 is 0. So is beta. And so is gamma. Gamma 11 plus gamma 9 plus gamma 8 is 0. So यहाँ से the moment you will add, you will get S11 plus S9 plus S8 is 0. So I am able to relate 11 with 9 and 8. Similarly, now S9 I can relate with S7 and plus S6. Now again I can relate S7 with S7 plus S5 plus S4 equal to 0. Okay, exactly in the same fashion. Again S5 will be related with S3 plus S2 equal to 0. And S3 can be related with S1 plus S0 equal to 0. Even S0 is defined here because S0 you can define as alpha 0, beta 0, gamma 0, which is 3. Okay, so now the base case is I know what is S1 and S0. So then S3 can be calculated. Similarly, base case on calculation of S4, S6 can also be done with X8 because S8 plus S6 plus S5 is 0. So using this recursion and a starting point, आप आराम से calculate कर सकते हो इसका next value क्या आने वाला. Okay, and it's fun. Like once you start the recursion, you can easily check like what's going to happen. So here the recursion that we have got is S of n plus 3 plus S of n plus 1 plus S of n equal to 0. Right, and you can see S1 is 0 because sum of root is 0 here. S2 similarly if you calculate you'll get minus 2. Once you know S1 and S2, आप आराम से calculate कर सकते हो next value. Right, so from here you can find the first 3 terms of the sequence. And S11 you can find by playing with n0, 1, 2, 3, 4, 5, 6, 7, 8. तो ऐसे अगर कैलकुलेट करोगे S11 का, you can check the value that will get is 0. Right? So the recursive relation is also used in this perspective as well. Like you can develop a recursion and try to attack. Sometimes in binomial also it can be used. Like recently JEE Advanced has already asked a question in JEE Advanced 2024. जिसमें unfortunately they ask very easier one with binomial theorem, but it's fine. But a similar question they could have asked is 2 plus root 2 to the power n is a to the power n plus b n root 2, where a n and b n is unique and they are of course integer and they are unique. They are unique because root 2 is irrational number, right? So first question is, what is the value of limit n tends to infinity a n by b n? Now this is a surprisingly beautiful question. So the way we do this for j is, since we know like 2 plus root 2 ka power n will give me 2 ka power n plus nc1 2 ka power n minus 1 root 2 plus nc2 2 ka power n minus 2 root 2 square blah 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 blah, and last will be root 2 ka power n. Whether n is even or odd, one thing is guaranteed because we'll have like root 2 square and these terms will be devoid of any irrationality. So all these will be integer plus, and we'll have these odd terms containing root 2. So I can take root 2 common and again some integer I2. So I'm sure like 2 plus root 2 ka power n can be written as I1 plus root 2 I2 from this binomial feeling. So what about 2 minus root 2 ka power n? If we'll do 2 minus root 2, just we'll have 2 ka power n minus nc1, 2 ka power n minus 1 root 2 and blah blah blah. So exactly it will be same thing as I1 minus root 2 I2. Because the magnitude wise these I1 and I2 will be same. Only minus sign will be reflected because odd behavior. ठीक है, तो यहाँ से एक अच्छा बात मिला. अच्छा बात क्या मिला? यहाँ से मिला जो 2 माइनस रूट 2 का पावर n can be written as directly an minus root 2 bn, because here I1 is an and I2 is bn. I can compare because root 2 was irrational. Okay, because I can compare because an minus I1 plus root 2 times bn minus I2 equals 0. And now I know this is integer. So now integer plus root 2 times of integer is 0. It's possible if and only if this is 0 and this is 0. There is no way. But if I tell a plus b equals 1 plus root 2, don't tell a equals 1 and b root 2, because someone can take a as 2024 and accordingly b will come something, right? That's important. अब देखो एक तो है जो दोनों साइड डायरेक्टली आई कैन टेक लिमिट ओनली इन वन लाइन सॉल्यूशन, लिमिट n टेंड्स टू इन्फिनिटी. वीकर सॉल्यूशन इफ आई टेक प्रोवाइडेड an and bn एग्जिस्ट एंड इज फाइनाइट. ठीक है, तो आप ले सकते हैं. तो अगर हम एज्यूम कर रहे हैं इट एग्जिस्ट, which again like non-JEE style, if this question comes in subject examination you have to do this, which I'll do as a second solution for those who are mathematically want rigorous solution. तो फिर अब 1.414 to the power n आ जाएगा. Limit n tends to infinity and this quantity is an minus root 2 bn. Limit n tends to infinity. अब ये quantity देखो it's like some fraction to the power infinity equals an minus root 2 bn. Limit n tends to infinity. A fraction to the power infinity will definitely die, because let's say 1 by 2 to the power infinity, it has to die. There is no way. तो 0 equals आ गया an minus root 2 bn when n tends to infinity. तो यहाँ से an by bn का जो वैल्यू आया वो डायरेक्टली root 2 आ गया at limit n tends to infinity. Okay, so I hope it is clear. This is how actually we can solve this question, and the answer for this problems will be directly root 2. But again, if you want to solve this from a recursive style, okay, so from recursive style what you can do is method 2. If I want to check here, so we can clearly note a1 is equal to 2 and b1 is equal to 1. आप इस definition से 2 plus root 2 का power n equals n plus root 2 bn. Now what if I'll multiply this with 2 plus root 2? So we'll get an plus 1 plus bn plus 1 root 2 is nothing but 2 plus root 2 to the power n into 2 plus root 2. So that becomes an plus bn root 2 and into 2 plus root 2. तो यहाँ से जो फाइनली मेरे पास आने वाला है वो आया 2an plus 2bn plus an root 2 plus 2bn root 2 and an plus 1 plus bn plus 1 root 2. So देखो now again an and bn plus 1 is integer. तो यहाँ से this can only happen if and only if an plus 1 minus 2n, I'm collecting all integer on one side, plus root 2 times bn plus 1 minus 2bn minus an equal to 0. So this will be the proper legal method of doing this. So now it's possible if and only if this is 0 and this is 0, because of these two are integers. Okay, now which reduces the given problem to two recursive problem. Okay, which reduces the given problem to two recursive problem. So actually we can again express this into one system, क्योंकि यहाँ से bn को आप यहाँ से लेके eliminate कर सकते हो. ठीक है, so we have basically two system, an plus 1 minus 2an minus 2bn equals 0. Similarly bn plus 1 minus 2bn minus an equal to 0. अब देखो JEE Advanced, in fact this problem I have already kept in a book, like how JEE Advanced can ask the problem. They'll not ask you to solve the recursion because that's not in the syllabus. लेकिन अब वो क्या करेगा, देखो binomial theorem के नाम पे बहुत ही अच्छा scam कर देगा. This they'll write as n plus root 2bn and now they'll create an option. ऐसा question डाला, option में डाल दिया a of 20 minus 2 times a of 19 minus 2 times b of 19 equals 0. So of course is correct because put n equals 19 here. ऑप्शन बी डाल दिया, b of 10 minus 2b of 9 minus a of 9 is 0. So this is also correct. Option C, now they'll put limit n tends to infinity an by bn and that is root 2. I hope you are getting the point. तो इस टाइप का जो गेम है ना वो जेई एडवांस आराम से खेल लेता है, इस टाइप्स का गेम आराम से खेल लेता है. अब एडवांस वाला एक ऑप्शन में ये भी डाल सकता है डायरेक्टली ए एन का वैल्यू. तो ए एन का वैल्यू आपका आ जाएगा हाफ टाइम्स 2 प्लस रूट 2n प्लस 2 माइनस रूट 2n. तो देखो ये बहुत ही एक शानदार क्वेश्चन बेसिक्स पे क्रिएट हो गया, ठीक है, बेस्ड ऑन रिकर्सिव रिलेशन. तो द पॉइंट इज लाइक आपको बेसिक पे ही खेलना है. अगर आप हम बहुत एडवांस लेवल के क्वेश्चन करवाने लगे और जो एक्सट्रीमली लेंदी हो और जिसका कॉन्सेप्ट बेसिक से सॉल्व नहीं हो, तो फिर वो जेई प्रिपरेशन का कोई मीनिंग नहीं है. देन देर आर सो मेनी यूट्यूब चैनल्स एंड स्पेशली यू गो एंड वॉच MIT लेक्चर्स, ठीक है, हार्वर्ड यूनिवर्सिटी लेक्चर्स. तो देयर यू विल एंजॉय मैथमेटिक्स. ओके, माई फोकस ऑन दिस चैनल इज डेफिनेटली टू गिव यू इनरिचमेंट इन मैथमेटिक्स, लेकिन एट द सेम टाइम रिलीवेंट होना चाहिए. मैं बार बार बोल रहा हूँ क्योंकि ऐसा बहुत यूट्यूब चैनल मैंने देखा है जो बहुत अच्छे शिक्षक हैं यूट्यूब पे भी, लेकिन उनका टॉपिक 90% इरिलेवेंट टॉपिक है जो जेई में कभी आने वाला नहीं है, ठीक है. और प्रॉब्लम्स भी ऐसा है जिससे आपको फंडामेंटल स्ट्रॉन्ग नहीं होगा. लाइक इफ़ यू हैव ऑलरेडी गुड फंडामेंटल देन यू कैन गेट एडवांटेज ऑफ दैट. ओके या आई एम कंप्लीटिंग. अब एक बच्चा पूछ रहा है जो इस चीज़ को हाउ यू आर एबल टू यू नो लाइक प्रूव इट. तो ये तो बाबू बहुत ही आसान है, अभी तो मैं प्रूव किया. n प्लस बी एन रूट 2 दैट इज़ गोइंग टू बी 2 प्लस रूट 2 का पावर n. अभी जस्ट प्रूव किया ए एन माइनस बी एन रूट 2 जो होगा दैट इज़ 2 माइनस रूट 2 का पावर n. अब देर किस बात की, ऐड कर दीजिए इक्वेशन. तो द मोमेंट यू ऐड इट यू विल गेट ए एन इक्वल्स हाफ टाइम्स 2 प्लस रूट 2 का पावर n प्लस 2 माइनस रूट 2 का पावर n and bn equals half times 2 plus root 2 का power n minus 2 minus root 2 का power n. Now even with this someone can find the value of limit n tends to infinity an by n minus 1 limit n tends to infinity या फिर limit a tends to infinity an by bn. अब इस दोनों एक्सप्रेशन को तुम डिवाइड कर दो एंड टेक मैक्सिमम पावर कॉमन, फिर भी आ जाएगा. जैसे देखो यहाँ से हम डिवाइड करके आपको दिखाते हैं सॉल्यूशन. तो अगेन दिस इज सम मेथड 4 और 5 वॉट एवर यू टेक. तो इसको द मोमेंट आई डिवाइड दिस इज गॉन. नाउ विच इज मैक्सिमम पावरफुल एट इन्फिनिटी, ऑफ कोर्स 2 प्लस रूट 3. इसमें से मैक्सिमम औकात वाले को बाहर कर दिया. सो वी हैव 1/2 माइनस रूट 2/2 प्लस रूट 2 का पावर n डिवाइडेड बाई 2 प्लस रूट 2 का पावर n को फिर बाहर कर दिया 1 माइनस 2 माइनस रूट 2/2 प्लस रूट 2 का पावर n. राइट, नाउ यू टेल लाइक इफ आई टेक लिमिट n टेंस टू इन्फिनिटी, तो अब फिर a n बाई बी एन क्या होने वाला है, a n बाई बी एन क्या होने वाला है. तो n टेंस टू इन्फिनिटी पे 2 प्लस रूट 2 आई हैव टेकन कॉमन. तो वी हैव 2 माइनस रूट 2 बाई 2 प्लस रूट 2, यहाँ पे 2 माइनस रूट 2. तो ये तो ऐसे ही कैंसिल हो गया. अब इस क्वांटिटी को देखो, इस क्वांटिटी को 2 माइनस रूट 2 इज अ फ्रैक्शन लाइक लेसर देन 2 प्लस रूट 2. राइट, तो कैन आई टेल लाइक ये जो होगा वो 0 को अप्रोच करेगा. अच्छा, बी एन का वैल्यू 1/2 रूट 2 आ रहा है. बी एन का वैल्यू 1/2 रूट 2 आया. अगर इसको सब्ट्रैक्ट कीजिएगा या रूट 2 विल कम, सॉरी दैट विल बिकम यहाँ पे एन ये जो है दिस बाय दिस विल बिकम वी हैव 1/2 रूट 2 is coming, that is half is coming, so that will be root 2 times this. Now n tends to infinity, this will be swa because fraction to the power infinity गया और ये भी फ्रैक्शन हो गया 2 माइनस रूट 2 लेस देन, तो ये भी हो गया स्वा. तो आंसर यहाँ से भी आ गया रूट 2. तो देखो इस तरीके से भी आप बना सकते थे, लेकिन आई थिंक द मोस्ट स्मार्टेस्ट सॉल्यूशन जो जेई टॉपर्स जो करेंगे वो ये है. आप जैसे ही रियलाइज का 2 माइनस रूट 2 कैन बी रिटन एज n माइनस रूट 2 इन लिमिट लो और यहाँ से खत्म कर दो. बट अगेन इफ़ यू हैव मोर इनसाइट यू कैन इट कैन बी सॉल्व बाय दिस. देयर आर मोर ट्रिग्नोमेट्रिक प्रॉब्लम, उसको भी हम रिकर्सिव से सॉल्व कर सकते हैं. एक बहुत ही शानदार सा प्रॉब्लम है साइन एन x प्लस 2π/3 साइन एन x प्लस 4π/3. उसको कॉम्प्लेक्स नंबर से भी देखा जा सकता है और रिकर्सिव से, ठीक है. फॉर एग्जांपल साइन 4 थीटा प्लस कॉस 4 थीटा वाला जो प्रॉब्लम है और साइन n थीटा प्लस कॉस n थीटा, तो उसको भी तुम चाहो तो उसको एस एन मानोगे तो एस एन माइनस 1 और एस एन माइनस 2 थीटा से तुम रिलेट कर सकते हो. देखो आइडिया अभी मैं दे रहा हूँ, एंड फिर ऐसा प्रॉब्लम मेरे बुक्स में सारे अवेलेबल है। अच्छा, बुक आपको अभी नहीं मिलेगा, उसके लिए 2 महीना वेट करना पड़ेगा, क्योंकि बहुत ही क्रिएटिव वर्क करना पड़ता है, एंड आई एम राइटिंग इट सिंगल हैंडेडली। तो देखो, जैसे सपोज वी हैव साइन एन थीटा प्लस कॉस एन थीटा से एक सम है एस एन। अब मैं इसको क्या किया, इफ आई मल्टीप्लाई विथ 1 सो एस एन कैन बी रिटन एज 1। अब 1 को मैं चालाकी से साइन एन प्लस कॉस एन को आई एम राइटिंग साइन एन लेजीली, सो आई एम राइटिंग साइन स्क्वायर प्लस कॉस स्क्वायर। तो अब देखो, इसको लिख दिया साइन एन प्लस 2 एन प्लस कॉस एन प्लस 2 विल कम, राइट, एंड देन वी हैव साइन एन कॉस स्क्वायर प्लस कॉस एन साइन स्क्वायर। मेक सेंस? तो अब देखो, दिस क्वांटिटी बिकम्स एस एन प्लस 2। अब इसको फिर आप थोड़ा एडजस्ट कर सकते हो। कैसे एडजस्ट कर सकते हो, साइन स्क्वायर कॉस स्क्वायर कॉमन लेंगे तो साइन एन माइनस 2 बन गया, एंड साइन स्क्वायर कॉस एन माइनस 2 हो गया। तो दिस बिकम साइन एन प्लस 2 प्लस साइन स्क्वायर कॉस स्क्वायर एंड एस ऑफ एन माइनस 2। सो अगेन यू सी द रिकर्सिव एस एन इक्वल्स एस एन प्लस 2 प्लस साइन स्क्वायर कॉस स्क्वायर कैन बी रिटन एज a sin 2 theta whole square by 4, right, and sn minus 2। तो देखो क्या बेहतरीन सा रिकर्सिव है बेसिक पे क्या बेहतरीन सा रिकर्सन क्रिएट हुआ है। अब इससे क्या फ़ायदा होगा, देखो द एडवांटेज दैट वी आ रहा है, अब जेई वाले शानदार क्वेश्चन से इस पर बना देंगे, ठीक है। इसको डिफाइन करके सपोज S10 S12 डाल दिया और S9 में रिलेशन पूछ दिया। आई होप यू आर गेटिंग माई फीलिंग, या। सो व्हाट दे कैन डू इज this, suppose S10 equals S12 plus sin 2 whole square theta by 4 and S of 8। तो अब they have given, consider the question। अब देखो जैसे क्वेश्चन कैसे how will create, consider Sn equal to sin theta का power n plus cos theta का power n for all n belonging to natural number, ऐसा डिफाइन कर दिया, और let Sn is this, okay। अब फिर कंसिडर अ सेट S एज ऑल थीटा बिलोंगिंग टू 0 to 2 pi such that S10 minus S12 okay divided by S8 equals 0। मतलब बेसिकली आपको ये दे रहा है S10 minus S12 equals 0, या फिर यहाँ पे सिग्मा उग्मा लगा के देखें पूछ सकता है, बस समझ रहे हो ना। ऐसे दे कैन पुट सिग्मा S10 माइनस S12 बाई S8 के बदले, अब देखो इफ आई गिव एनी वैल्यू, लेट्स से Sn, दिस इज Sn प्लस 2 Sn माइनस 2, ऐसा करके वैल्यू पूछ दिया, सिग्मा n रनिंग फ्रॉम लेट्स से 2 to 10, दिस इज इक्वल टू 0, सो फाइंड नंबर ऑफ थीटा। अब क्लियरली ये क्वांटिटी जो है वो कुछ नहीं है, ये बेवकूफ़ बनाया जा रहा है आपको, इस साइन स्क्वायर 2 थीटा बाई 4। अब फिर इसको 0 करके साइन 2 थीटा 0 कर लो, इट्स मल्टीप्लाई विद जस्ट सम कांस्टेंट बिकॉज 2 to 10 इज हाउ मच, 9 टाइम्स, राइट। तो ये तो साइन 2 थीटा 0 हो गया। नाउ साइन 2 थीटा इक्वल्स 0 मीन्स 2 थीटा इक्वल्स n पाई, थीटा इक्वल्स n पाई बाई 2। अब इस विंडो में आप चेक कर लो, तो 0 वर्क करेगा, 1 वर्क करेगा, n का वैल्यू 2 पे पाई आएगा, 2 वर्क करेगा, 3 वर्क करेगा, 4 वर्क करेगा। तो यहाँ से 5 सॉल्यूशन आ जाएगा, ठीक है। या फिर डायरेक्टली आपसे यही पूछ सकता है वो जेई वाले, डायरेक्टली देखो डाक्स व्हाट इज S10 यू नो लाइक माइनस S12 इक्वल टू, अब कुछ भी पूछ लेगा यहाँ पे S8 का वैल्यूज देके, या फिर S8 के टर्म्स में आपको पूछ सकता है, या फिर उसको डिवाइड करके लिमिट विमिट पूछ लेगा। सो आई होप यू आर गेटिंग द पॉइंट, मतलब हाउ प्रॉब्लम्स कैन बी सेट इन रिकर्सन। वैसे तो मुझे और रिकर्सन याद आ रहे हैं, ये हर एक चैप्टर से PNC से भी कनेक्ट कर सकते हैं। वेक्टर्स में भी रिकर्सन है, वी कैन डिफाइन वेक्टर Bn क्रॉस अ न्यू वेक्टर एज अ Vn प्लस 1 वेक्टर्स। कॉम्प्लेक्स नंबर्स में Zn कैन बी डिफाइंड इन टर्म्स ऑफ Zn माइनस 1 रिकर्सिव है। तो ये पूरे के पूरे सिलेबस में रिकर्सिव प्रॉब्लम जो है वो पूछा जा सकता है। जेई हैज ऑलरेडी टच दिस विथ रिगार्ड टू PNC, एंड थोड़ा बाइनोमियल में उतना अंदर गया नहीं है, लेकिन शायद वो जाने वाला है अगले साल या अगले साल। तो आई होप यू हैव एंजॉयड दिस, एंड अगर आपको लेक्चर्स बहुत ही पसंद है तो आप मेरा कोर्स भी ज्वाइन कर सकते हो, ठीक है, जो कि व्हाट्सएप लिंक इज़ ऑलरेडी देयर। आई नो लाइक द टाइमिंग वाज टू मच,